Hello students, in this video we'll discuss the Poisson Integral Formula. Let's consider the Dirichlet problem, which is Laplacian of u is equal to 0, and u of e to the I theta is f of theta is continuous on the boundary, right? It's a continuous function. On the unit circle. Okay, excellent. And so now we know that since u is harmonic, right, it satisfies the mean value property, right? So u satisfies the mean value property. Okay, in other words, u is the real part of a holomorphic function, right? And that holomorphic function satisfies the mean value property, so does u, right? So in other words, u of 0 is 1 over 2 pi I. The i's cancel out, integral from 0 to 2 pi of just f of theta, the boundary values, the boundary data, d theta. Great. Of course, this gives me the value of u at the origin, right? How do we find the other values of u, right? Let's let z0 be a point in the disk, and let's consider our Blaschke factor, and consider the Blaschke factor. B of negative z0 of z, which is z plus z0 over 1 plus z0 bar z, like that. Of course, this is a conformal automorphism of the unit disk. Is a conformal automorphism of the unit disk. Okay, great. And so what I can do now is I can compose, this is a holomorphic function, so I can consider the function u tilde of z is going to be u of b negative z0 of z. This is what? If I want u to be harmonic, right? If u is going to be harmonic, and what? And I want to represent u, well, this is a harmonic function composed of the holomorphic function. It's harmonic, so u tilde is harmonic. U tilde is harmonic. And so what can I say about u tilde of 0? What is u tilde of 0? So u tilde of 0, if I plug in 0 for z over here, plug in z equals 0, I just get z0, right? So u of z0 is equal to u tilde of 0. And u tilde of 0 is going to be what? It's going to be 1 over 2 pi, the integral from 0 to 2 pi, of what? Of the boundary values of u. So I'm going to plug in a u of what? Of b negative z0 of e to the I t dt. Like this, okay? Excellent. And so now I want to change the coordinates over here, right? Good. That, of course, is just my theta value, right? Excellent. So let's change coordinates. Because I want to get what? I want to write this in terms of what? I want to write this in terms of the boundary values, right? I know that b maps the boundary to the boundary. B of negative z0 maps the torus to the torus, right? That's great. And so now what we're going to do is we're going to introduce a new variable. Let's let e to the is be equal to what? Be b of negative z0 e to the it, like that. Of course, I know what the inverse of b negative z0 is just b of z, right? And so this implies that b z0 of e to the is is equal to e to the it. Okay, now I need to get dt out of this. I'm going to differentiate this, right? So take the differentiate. If we do so, what are we going to get? If we do so, we're going to have b0 prime of e to the is times what? Times I e to the is, right? That's the derivative with respect to s, is equal to, let's say ds, like that, is equal to what? Is equal to I e to the it dt, but e to the t is just the b0, right? So I can cancel out the I, and so that says that b z0 prime of e to the is over e to the it, which is bz0 e to the is ds is equal to dt. Okay? Great. Okay? Now, what's happening over here is that this is a very important quantity over here. We're going to calculate this explicitly and see what it gives us, right? But what's the key thing? The key thing is we need to differentiate this and plug in what the origin is, right? So it turns out that a calculation shows, this implies that, let's see, so we have a 1 minus z0 squared over what? Over e to the is minus z0 quantity squared ds is equal to dt, okay? So that's just a calculation. So if you do this calculation, we've seen this before with the Blaschke product, you get exactly this. This is how you prove it maps the boundary to the boundary. So this is what we get over here. We get this change of coordinates over here. And also notice that one thing to remark on before we continue this calculation, so remark. This is the logarithmic derivative of this Blaschke factor. Okay, no surprise there. So now I'm going to change the coordinate. So it's u of z0. So u of z0, therefore, so u of z0 is going to be what? It's going to be 1 over 2 pi, the integral from 0 to 2 pi, and then it's going to be u of what? Well, that was my what? That was my e to the is. This is going to be u of e to the is, and then times dt, which is this expression over here, times 1 minus z0 squared over e to the is minus z0 squared ds, right? And this is the Poisson integral formula. So this is our Poisson integral formula. Beautiful. So in other words, I'm able to write down the value of the harmonic function at any point in z0 in the disk against integration against this kernel. And this kernel called the Poisson kernel, right? So note, so this thing over here, I can look at p zeta of z, right? P zeta of z, which is 1 over 2 pi. And then I have had a 1 minus mod z squared over zeta minus z squared is the Poisson kernel. Okay. We'll study the Poisson kernel extensively in further videos, but the whole point of this is that this Poisson kernel is actually what's known as an approximation to the identity. So this is an approximation. Of course, what are the variables over here? The zeta lies on the torus and the z lies on the disk, right? Actually, I just wrote a paper about this. You can check it out online. And this paper basically says if you replace zeta with an analytic function, so this is a harmonic function of zeta. It's a harmonic function of zeta. If I replace zeta with a holomorphic function on the disk, I get another harmonic function by the Herglotz representation theorem. That has to be a measure, and that measure is called the Alexandrov-Clark measure, and it helps us understand composition operators. So it's a very, very useful thing. So this is, so yeah, it's a very, very important thing. So, yes, excellent. So, and this is an approximation to the identity, which will allow us to recover the boundary values by passing to the limit, right? And so in particular, one thing that's really important is, of course, as z goes to zeta, right? As z goes to zeta and zeta is equal to 1, then what you're going to get is you're going to get a delta function, right? So that's exactly what I mean by approximation identity. We'll discuss that a lot in further videos. Thank you very much.